Alaikum warahmatullahi wabarakatuh. Welcome to Mewa Digital Hub channel. Today's remedial lesson will be about or will be on air and combustion. Okay, so basically we're going to study this today. As for the other lesson, maybe we might cover acid bases and indicators, but today I want to focus on air and combustion. It's a widely asked topic in KCSE as well as for Form 2s, Form 3s, and Form 4s currently. So let's start. So first thing that you need to know is what is air? What is air? Now air is a mixture of gases. Air is just a mixture of gases. So there are different types of gases that are in air. So each of those gases usually play a very crucial role in our day-to-day life. So and those gases include nitrogen, oxygen, we have noble gases, we have carbon dioxide. If you're a grade 7 student, then you can call it carbon dioxide. But if you are Form 2 to Form 4 student, then you should refer to it as carbon dioxide. We also have water vapor. So the composition of each gas in air usually varies from one gas to another. As for the nitrogen, usually it consists of the 78%, usually 78%, and is the most abundant gas, which is largely unreactive. Usually, the uses may include making of nitrogenous fertilizers, used in the manufacture of ammonia during the Haber process stage, and etc. The second gas, which is oxygen, it's 21%. Okay, it's 21%. Its main composition is 21% and is used by living beings for respiration and also for combustion, for welding, for climbing mountains, and etc. We have noble gases. Noble gases, argon is just a part of a noble gas. Another name for noble gas, we also refer to them as inert gases, or uh, what do you call it, rare gases, and it's usually 0.97%. Most of the time it's used in lighting and also in welding, okay, especially in filling the bulb filament or the light filaments. We also have carbon dioxide as our other gas, and it's usually 0.03%, and is also used for photosynthesis, also called a greenhouse gas. We also have water vapor, which is variable and its percentage changes from time to time. Okay, so now how do you separate these gases? Right, how do you separate these gases? And we separate these gases with the help of a process called fractional distillation. So first thing, we liquefy the air, then we then use fractional distillation to separate those gases. But now, for the carbon dioxide is usually separated when you pass the air through calcium hydroxide or maybe sodium hydroxide, whichever reagent that might react with carbon dioxide. So that just leaves you nitrogen, oxygen, and noble gases, which you need to apply a process called cooling. Also apply pressure into it around 200 atmosphere. So we cool it so that it can become liquid air, and then that's when uh, we do fractional distillation into it, or we boil it and get different fractions. Okay, so different gases usually boil at different temperatures. Okay, they usually boil at different temperatures. Oxygen has its own temperature, nitrogen has its own temperature, and also argon also has its own temperatures. Okay, so the first, when you're boiling them, the first gas to boil out first is nitrogen. because it has the lowest boiling point. So it boils off first and then it's collected at the top of the column. Then we have argon. Argon boils this secondly with a boiling point of negative 186 degrees Celsius, and then lastly is oxygen with a negative 183 degrees Celsius, allowing for the efficient separation based on distinct boiling points. So that's just a point I've repeated there. Now we have oxygen, and that's our main discussion for today. Now, oxygen usually has its own physical properties and as well chemical properties. Now, the physical properties of oxygen is that it is colorless. You can see it doesn't have a specific color or distinct color. It's odorless. It doesn't have a specific smell to say so. It's tasteless. Okay, it is a tasteless gas. It's slightly soluble in water, and it's slightly, most probably, is denser in than air. So it's denser than air. Someone was to ask you if oxygen is denser than air, then you just say it. Yeah, you say yes. So if something is denser than air, most probably it will be collected using the downward delivery, not the downward displacement. I think there's a correction there, but you use downward delivery to collect that type of gas and not upward delivery. Another name for downward delivery is what we refer to it as upward displacement of air. So then it is neutral to litmus paper. Is a neutral gas. It's neither acidic nor is it basic. As for the chemical properties, usually oxygen supports combustion. So it supports combustion. So most of the times it's very crucial for burning processes. It also reacts with most metals to form oxides. It combines with metals to form basic oxide. For example, you have copper 2 oxide, you have sodium oxide, you have potassium oxide, and etc. And also combines with non-metals to form acidic oxides. A good example is sulfur 4 oxide, you have carbon 4 oxide, and etc. Some oxides are usually amphoteric. Why is it so? Why do we refer to them as amphoteric? Because they exhibit both acidic and basic properties. So they not specifically say as acid, or it's not specifically as a referred to as a base. So I think you got that. So just repeating again, we have amphoteric, we have acidic oxide, we have basic oxide, we also have neutral oxides. For example, you have carbon 2 oxide, nitrogen 1 oxide, and etc. And usually they don't exhibit acidic. They don't exhibit neither they exhibit neither acidic nor basic properties. So it's just neutral, just like the way you see it. Okay. Now, how do you prepare oxygen? Now, oxygen is usually prepared uh, through three ways, but basically there's a fourth way. Okay, there's another fourth way of preparing oxygen, something that you should know. So, but the first way that you've been taught, okay, is the composition of hydrogen peroxide. So you decompose the hydrogen peroxide decomposes itself when it's exposed to the atmosphere, and it decomposes to form water and oxygen. But with the help of manganese for oxide acts as a catalyst. It doesn't react with the hydrogen peroxide. It just acts as a catalyst, speeds up the rate of reaction without being consumed. Okay. The second one is when you take potassium manganate 7. So if you heat potassium manganate 7, you get potassium manganate 6. Okay, potassium manganate 6 oxide and manganese 4 oxide, and as well as oxygen gas. So that's something that everyone should know as well. Now we also have heating potassium chlorate. Okay, when you heat potassium chlorate, you get something called potassium chloride plus the oxygen gas which you wanted it at the end of the reaction. Okay, so hopefully I think you've understood that. So there's another one, there's a fourth way of preparing oxygen. You just need to research on it. That's an assignment I'm giving you. So if you have the answer to that question, then you can comment it on the box comment section, or you can go to the Mewa org website and clarify yourself. Test for oxygen. Now, how do you test for oxygen? Right. Now, usually test for oxygen if you introduce a glowing splint into a test tube containing oxygen or the gas suspected to be oxygen. So what it usually does, it relights the glowing splint. So the test for oxygen is just relighting a glowing splint and not a burning splint. Those are two different concepts. There's a glowing splint and there's a burning splint. So it relights a glowing splint and not a burning splint. This is because of its property to support combustion. Okay, so this test is very unique only to oxygen and is also a standard procedure in many chemistry practicals. We have combustion. Now, if someone was to ask you what combustion is all about, then you answer them by saying that it's a chemical process which requires oxygen, okay, or is the rapid reaction of a substance with oxygen, usually from the air, and is accompanied by the release of heat and light in the form of a flame. So that is combustion. And now combustion is uh, categorized into two, which are complete combustion, and you also have incomplete combustion. Now, complete combustion, it occurs when you have sufficient oxygen. Okay, when you have sufficient oxygen, so the substance that is there, it combines with the sufficient oxygen, so to give you a specific product. So for example, let's take methane. When you take methane, react to fully sufficient oxygen, you get carbon dioxide and water as a result. For incomplete combustion, so here under complete combustion, the flame is usually cleaner and it's very ideal. Okay, it's a very ideal burning. So under complete combustion, it usually occurs with limited oxygen. This is where now a hydrocarbon, maybe it's methane or ethane or any hydrocarbon, reacting with a limited oxygen to give you carbon dioxide uh, and water as your products. So carbon dioxide is basically a poisonous gas. That's why many students are prescribed to to not conduct these types of experiments. Okay, so whenever you have a G well at your home, make sure the place is ventilated. Otherwise, the carbon will react with the limited oxygen to give you carbon dioxide, which when inhaled, it might bind with the hemoglobin of the red blood cells and therefore further preventing the transportation of oxygen within your body. So it's basically a very uh, a very what you refer to it as a very dangerous compound. So combustion of different elements. We have magnesium. You react magnesium with oxygen. It gives you a bright white flame or a white blinding flame. We also have sulfur, which reacts to give you a very blue flame, a very characteristic blue flame, and it forms sulfur dioxide. As for magnesium, it forms a white solid magnesium oxide. We also have phosphorus, which burns with a bright yellow flame, forming white solid phosphorus 5 oxide. Okay, now we have rusting. Now rusting is a common form of corrosion that degrades the iron steel. It's just hydrated iron 3 oxide. That is what we refer to it as rusting. Other substances can rust as well, but now the main substance which we need to know, or we ought to know, is iron. Okay, so rusting usually requires water or moisture. We also require air, which is oxygen. Okay, We also have electrolytes. Now electrolytes, you should know that as well. We have things that usually accelerates the rate of rusting, especially when it comes to acid and salts. Okay, that is why metals or cars that are very near to the sea usually corrode faster compared to those that are on the highlands. Okay, this is because the presence of salty water, the saltiness in it usually speeds up the rate of rusting. And now we need to know even the prevention measures that you need to conduct in terms of preventing rusting. We have, for example, electroplating. Okay, where we usually use electricity to plate or to coat that substance which we don't want it to rust. We have galvanizing, we have painting, we have oiling and greasing. Those are prevention measures of rusting. Okay, so in case you don't know, you know right now. So we have alloying, we have galvanizing, we have sacrificial protection, electroplating, and etc. Sometimes we coat a metal with another metal, so that the other metal which coats it is coats the inner metal. It's rust faster compared to the inner metal. Okay, so we coat many metals with aluminium, we coat it with zinc, we coat it with many metals which are somehow very reactive compared to other metals. Okay, the last slide is about air pollution. Okay, sorry, I was to end. I don't know why. I forgot that there's the last slide. So there's air pollution control measures. The main pollutants we have is carbon monoxide, carbon dioxide, we have sulfur oxide, we have nitrogen oxide, we have smoke and dust. So how do you measure? How do you do a control measure for these types of substances? Okay, but before we look into control measures, just know that carbon oxide is usually a colorless, odorless, poisonous gas that comes from incomplete combustion. Sulfur dioxide or sulfur oxide and nitrogen oxides are gases that dissolve in rainwater to form acid rains, damaging buildings and also rooftops and ecosystems. We also have smoke and dust that usually cause respiratory diseases and reduce visibility. The control measures usually do something called catalytic converters, where we convert the harmful pollutants like carbon dioxide into less toxic gases like carbon dioxide, nitrogen, or water. So we use clean fuels, okay, especially like, for example, biofuels, natural gas. Those are called renewable energy sources, which reduce pollutant emissions. We have industrial scrubbers. They are devices used in factories to just remove gases, pollutants like sulfur oxide and particulates or particles from industrial exhaust streams before release into the atmosphere. So I think we can conclude the lesson there. So sorry for that. I thought the slide was about to finish, but all in all, just like usual, don't forget to subscribe to Mewa channel, and don't forget to recommend this session to your other friend. I don't have much to say now. Wassalamu alaikum wa rahmatullahi wa barakatuh.